basically had to fit into their existing ecosystem, not to reinvent everything from the scratch, because obviously this wasn't possible. So starting with the scalability, this is the presentation, by the way, which is scheduled more or less for 1 hour. We need to do this in 30 minutes. So I'll try to compress this content as much as possible, but I think we can share the slides later on with you, so you can go through the content in your own pace. But I think it was Stephen who referred yesterday to this benchmark, which was done, I think, September 2014, with a 1 trillion triples stored in Exadata, and that answered our concerns. So basically, we were a little bit afraid whether we are able to store the relevant information in the right way and to process this efficiently and with right performance. And this sort of answered all our doubts. So first of all, 1 trillion, and I think that Stephen also mentioned that we can easily exceed this threshold up to 3, I think. He mentioned something like this. So again, this leaves us huge space for data to store and process them efficiently on the database side. And as we have more than 20K of events per second, these pieces of communication, little pieces of communication, this number is going to grow, and the number of data which we are storing. This will grow and will grow really fast. Obviously, we are not willing to back up the internet, because that's not the purpose here. But we prepared a series of filtering mechanisms based on risk, based on content, based on other stuff, to limit the number of the content. But still, it's going to be a lot. So with this kind of approach, we are more than sure that we can handle this. Secondly, what was, I think, very important for us, so how we are going to prepare, and I think already answered to this question with the previous slide, saying that we were already starting from the beginning, we were thinking about triples. So we were thinking about graph representation and graph-based storage, because we thought that classical, I would say, relational data representation, it's not mentally, I would say, close to the way how those relationships look in real life. Obviously, you can do this, but this column representation, it's hiding a little bit the relationships. So we were thinking about, and what is important, it's with this kind of model, you have very strictly specified formats. So you need to think about the model. You need to think about how you structure the data from the very beginning. Obviously, you can add a number of flex fields, but this makes all this schema a little bit not performant at some point in time, and it's making this really hard to maintain at some point in time. So we thought that there must be some better way of doing this, and that's how we found out that basically those relationships are better, or at least better represented when we do have graph representation underneath. So and this all started to be even more important when we discovered how much we can get out of the messages that are exchanged. So obviously you already heard a location, name of the person, maybe date of the message where it was sent. These are, I would say, basic ones, but we can really get out of those messages much more than that. Coordinates, device information, IP address, potentially sentiment, extraction of the entities. So for example, time mentions, locations, hashtags, and all this stuff can be extracted and should be extracted from the messages and should be stored and used for further analysis. So this all clearly proved us that we need really performant and fully blown NLP engine for doing this let's say, inspection of our text enrichment of the messages. And I've already mentioned about security aspects, so maybe I'll quickly skip through this slide. But obviously, we had to make sure that we are going to separate the data in the right way, and we are going to protect the data in the right way in the places where we store the data, but also everywhere else where the data it's transmitted. And application diversity, that's what I've already mentioned. This is something which I think it's obvious to everyone. And collaboration, that's the last but not least, which I'd like to point out here, we do have many tools for doing already some sort of analytics on top of graphs and on top of data that we store. But we very soon found out that if I may refer here for social relationship management, which is Oracle product, by the way, in the cloud, who provides an ability to subscribe to certain topics of discussions which are exchanged in the internet or which are posted in the internet. And SRM, it's collecting all the data and provides us basic functionality to analyze the data. But we soon found out that it's too generic. This is more for marketing purposes. So if you are, I don't know, if McDonald's, you would like to know what people are thinking and tweeting about you, this is a tool for the job. So you would like to probably get this kind of reports with this kind of platform. And on the other hand, on the opposite and you do have this advanced analytics, so really hardcore set of functionalities for data analytics, for doing all this complex stuff. But this is not, on the other hand, useful for those officers, for those analysts working in the intelligence agency, because these guys don't have this kind of skills. So this is something which is a little bit difficult for them also to learn. So we've clearly found out that we need something in the middle, which is providing enough analytics for them that they would use, but it's also simple enough and able to use the data that is coming from the external world very efficiently. And now, before maybe we go to the solution itself, this last slide, because those kind of questions may pop up in your heads in a few moments. How we calculate risks in the system. Risks are at the moment this is oversimplification, but to give you a little bit of taste how we are doing this, we are taking into account the distance of the people. We are taking into account content, and this is something which might be important for you as you are as your background is in spatial and location-enabled systems. We are also considering location-based alerts and location-based risk assessment. So basically, if someone is within 2 kilometers, that's why I also took this slide, because this might be important for you, that we are using this kind of mechanism. Then we might create the geofences where someone is entering this geofence. The alert is triggered, and particular person it's highlighted as a potentially dangerous object who should be monitored, and obviously historical activities. So, for example, if someone was quiet for the recent several months and now he tweets like crazy, and what's even worse, he's using all the terms like jihad and everything else, what is a little bit scary for us, this might be a person who should be taken to some sort of different level of inspection, let me say like this. So just basics of the risk assessment module and how it all works. So basically we do have a pipe. First of all, we are starting with natural language processing, maybe other way around. We are starting with collecting the data. So we are starting with getting the data out of the internet space. We do have a media proxy component for doing this job. I will show you this in a moment. And then we are putting the data in sort of a funnel, which is trying to reduce amount of data, but also do the right job for doing this text enrichment. So first of all, natural language processing, linguistic sentiment analysis, and entity extraction, and there we put this in a cross-domain secure database, which is used by other systems through the integration layer, or by real-time monitoring systems, or by user-driven analytics or visualization. Don't be misguided by the word database. We are using here a little bit of the I think it was called on Monday a polyglot model. So we are using different tools and different types of storages for storing different type of data. So we are using big data appliance for storing this low density data. Then after the data are refined and after the natural language processing is executed, we are storing the data in the graph format in the graph data store. And this one, it's based currently on two versions. We have two flavors, let me say, of the social intelligence. One semantic graph based, and one it's property graph based. I will show you them in a moment. So another slightly more detailed view on the architecture. So how it looks in the details. Again, on the left-hand side, we do have those external data sources. Here we have media proxy